Every star begins in darkness, cold clouds of gas and dust waiting for gravity's tug. As regions grow heavier, they collapse, heating up until a hidden embryo called a protostar forms. A spinning disk feeds the baby star, gas falling inward while jets blast along its poles. Those jets clear cavities, announcing a star in the making to the surrounding cloud. When the core grows hot and dense enough, hydrogen nuclei begin to fuse into helium. Fusion releases light and heat that push outward, balancing gravity. The star arrives on the main sequence. That's the long, stable phase where most stars spend their lives. Mass sets the tempo. Small red dwarfs sip fuel for trillions of years. Giants burn bright and fast. Our sun, a medium star, will shine about 10 billion years. It's roughly halfway through its story today. During this calm, stars host planets, power climates, and bathe worlds in life-enabling energy. Eventually, core hydrogen thins, fusion shifts to a surrounding shell, and the core contracts and heats. The outer layers puff out. Our sun will expand into a red giant. At higher heat, helium lights fusing into carbon and oxygen, another round in the star's furnace. Aging giants can pulsate, their atmospheres breathing in and out like slow, starlit tides. Winds carry away outer layers, sprinkling space with carbon dust and complex molecules. For sun-like stars, the finale is a planetary nebula, glowing gas lit by a shrinking core. That core becomes a white dwarf, Earth-sized, incredibly dense, slowly cooling for billions of years. In close binaries, a white dwarf can steal gas. Too much may trigger a brilliant nova or Type 1a supernova. Heavier stars live faster. They race through fuels, hydrogen, helium, carbon, building layers like an onion. Fusion of elements up to iron releases energy. Beyond iron, fusion costs energy, so the core can no longer hold gravity back. The core collapses in a heartbeat, rebounds with a shock, and a supernova rips the star apart. This is stellar recycling. Calcium in our bones and iron in our blood is forged in such explosions. The leftover core can become a neutron star, matter crushed so tight that atoms no longer exist. If its magnetic poles spin past our line of sight, we see a pulsar, precision beams like a cosmic clock. Some neutron stars are magnetars with magnetic fields trillions of times stronger than Earth's. If the core is massive enough, it collapses into a black hole where gravity allows no escape, not even light. Shockwaves squeeze clouds, triggering fresh star birth, one generation lighting the next. Young stars often form in clusters, siblings moving together before drifting apart over millions of years. Old globular clusters hold some of the galaxy's earliest stars, fossils of the young universe. In many disks, planets carve gaps as they grow, signatures of worlds assembling around their suns. Variable stars act as yardsticks. Their rhythms help us measure distances across the galaxy. Back in nebulae, newborn stars ignite, their radiation sculpting pillars and blowing bubbles through the cloud. Our sun will swell, shed its outer layers and leave a white dwarf, no supernova required. Watching starlight dip as planets transit lets us weigh stars and read the chemistry of far-off skies. New generations inherit heavier elements, building rocky planets, complex chemistry, and the possibility of life. Look up and you're seeing many ages at once. Infant blue stars and dying red giants sharing the same sky. Different masses, different fates, giants explode, suns shed, dwarfs cool, and some cores become the densest objects known. The dust from death seeds new systems, locking star stories into planets, moons, and maybe biology. Spectra, rainbows of starlight, reveal temperature, speed, composition, even how fast a star is spinning. When massive stars merge, space-time itself rings. Detectors on Earth hear the final notes of stellar lives. From dusk to dawn, stars write the universe's timeline, turning gravity and time into light. And in their endings, they begin again, recycling elements, resetting clouds, and restarting the cosmic cycle. Birth, life, transformation, and legacy, the life cycle of a star is the universe's favorite story. Like, comment, and subscribe for more videos like this.